We're going to talk now about relations and functions. A relation is a set of ordered pairs. In other words, a relation is a set of points. A relation can be expressed graphically as a line or a parabola, etc., or pictorially using an input-output diagram, or as a table of values, or in many other ways. A graphical representation of a relation could be a parabola as shown, or it could be an input-output diagram, or it could be a table of values. The domain is the set of all x values of a relation, and the range is the set of all y values of a relation. The domain and range are usually stated in set notation using brace brackets. Example, determine the domain and range of this relation. Well, we see that our x values are 1, 4, and 7, and our y values are 2 and 3. So in this case, the domain and the range are fairly easy to state. We want to state them with brace brackets because when you do that, you're saying the set of 1, 4, and 7. And a domain or a range is a set. So we want to use brace brackets to indicate that it is a set. We call that set notation. Now, what about the domain and range of this relation? Well, we see that the domain is all the x coordinates, -1, 4, and 5, put in set notation. The range is the set of 3 and 2 and 3. But in a situation where the same value is repeated, we only state each value once and we order the terms from least to greatest. So we'll say that the range is actually the set of 2 and 3. Looking at this relation, it's a set of ordered pairs, specifically 4 of them. If we want to know the domain and range, we can list the coordinates of each point. Now, the domain is the set of -4 and -2 and 1 and 2. And the range is the set of -1 and 2. Now, you might be tempted to say the range is the set of -1 and 2 and 2 and -1, but we only want to state each value once. So we say it's the set of -1 and 2. Looking at this relation here, we want to state the domain and range of it. The leftmost point of this relation is at an x coordinate of -4. And from there, the points include every x value to the right of 4. Putting them on a x-axis would look like this. So looking at that, we can say that the domain is the set of all x element of the reals such that x is greater than -4. Now, you don't have to use the method that I'm using right now, where you shade in portions of the x-axis that correspond to values of x that are belong to points on the curve. But you can do it this way if you want. And the reason that we're using this notation here, x is an element of the reals, and then stating the condition on x, the reason that we're doing that is because there are an infinite number of x values, and so we can't simply list them the way we could in the earlier questions. We have to actually use a more sophisticated method. Now, talking about the range, we have these points here. We see that the lowest point in this vertically has a y value of -1. And from there, the points on the relation include every possible y value above -1. And so it looks like this. And looking at that on the y-axis, we can say that the range is the set of all y element of the reals such that y is greater than -1. Now, determining the domain and range of the relation shown here is interesting. First, we'll talk about the domain. We see that the rightmost point on the function is at x equals 4, and every x value to the left of x equals 4 is included in the domain because every x value to the left of to the left of 4 will be the x coordinate of a point or two on the curve. So we can state our domain like on the bottom of this slide. Now, talking about the range, we can different ways of doing this, and as long as you have an accurate way of doing it, that's fine. One way is to look at the vertex and then look at the upper arm of the parabola. If you're only looking at the arm of the parabola shaded in yellow right now, you see that uh, all the y values greater than -2 are y values associated with a point on the function, in other words, elements of the range. And if we look at the lower branch of the parabola, a similar process unfolds. And so we see that putting them together, we really just have one big range, which is every value on the y-axis. So literally any real number is the y-coordinate of a point somewhere on that sideways parabola. So we can say that the range is the set of all y element of the reals. We can also, if we want, just simply write it this way. When you write a R with two vertical lines like I just did there, that means the set of all real numbers. So we can say the range is equal to the set of all real numbers. That's another way of writing it. But you can also write it this way if you want. Now, determining the domain and range of the relation on the right, we're going to focus on looking at all three sections to do the domain. So the first portion is the little portion that goes from the little portion on the far left. It goes from an x value of -5 to a x value of -4. Now there's a closed circle at -5 and an open circle at -4. That means that there's actually no point with an x value of -4. It goes up to, but not quite to -4. It gets infinitely close, but it doesn't actually reach -4. Now looking at the second part, we see that every x value possible between -1 and 1 is represented somewhere on that second part. And finally, the third section has a leftmost x value of +3 open circle and a rightmost of 5 closed circle. Now, putting all that together, we get -5 is less than or equal to x is less than -4. -1 is less than or equal to x is less than or equal to 1. And finally, 3 is less than x is less than or equal to 5. Now, looking at the range, we're again going to look at the three parts of the function. So looking at the first part, the one I'm pointing to right now, if you look at the verticality of that, you get a range that looks like the red shaded in part of the y-axis. Now, let's look at the second part. Let's look at the second part right there. Well, shading in that those y-coordinates on the y-axis will result in something looking like this. Now, notice that we have right there, we have an open circle that got shaded over. This means that a y value of 2 that was previously not in the range is now in the range. And since a given y value is either in the range or not in the range, we see that now the y value of -2 is in the range. In other words, there's no more open circle. So in short, if you use this method that I'm using now, which is optional, then remember that if you shade over an open circle, it's no longer open. And finally, the third portion on the far right, the minimum y value is -2. There's an open circle there. And the maximum y value is 3. There's a closed circle there. And so we can shade in that portion of the y-axis that I've shown. Okay? Now, putting it all together as asking yourself yes or no, is each value shaded or not, we can actually simplify this, and our shaded in portion of the y-axis can be simplified to this one shaded in portion. And so we can state our range quite simply. It's all the values from -2 to 4. -2 is not included, 4 is included. Now, I've seen students do this up at the top. They'll say, y is an element of the reals such that, and then they'll focus on the first part, and they'll say -1 is less than or equal to y is less than 2. And then they'll focus on the second part, and they'll say 0 is less than or equal to y is less than or equal to 4. And then they'll focus on the third part, and they'll say -2 is less than y is less than or equal to 3. If you do this on a test, you lose marks because it's not efficient. I'm not interested in how you figured out what the range is as the final answer. I am within the course of your solution, perhaps, but as the final answer, I want the most efficient answer you can give me. And so what I want is the one that is boxed in at the bottom, not the one that I'm scribbling out up top. The one I'm scribbling out up top is inefficient. Definition of a function. A function is a relation in which each valid x value can be paired with only one y value. So we could look at this relation and ask if it's a function. The answer is yes. When x equals 1, we know that y equals 2. When x equals 4, we know that y equals 3. And when x equals 7, we know that y equals 3. There are never two or more y values paired with one x value, so we know that the relation is a function. Now, another example is determine whether the following relation is a function. And the answer here is no. When x equals -3, y is 5. This part is certain. However, when x equals 6, y could be 9 or y could be 12. We don't know. So in other words, there exists an x value paired with two different y values. Therefore, this relation is not a function. Next, we want to determine whether this relation is a function. And the short answer is yes. When x equals -1, y equals 3. When x equals 4, y equals 2. And when x equals 5, y equals 3. For every possible x value, we know with certainty that what the associated y value will be. And therefore, this relation is a function. Next example, determine whether the following relation is a function. The short answer is no, it's not. Granted, when x equals 4, we know that y equals -3. However, when x equals 2, y equals 5, or y equals 7. In other words, when x equals 2, we don't know what value of y will be paired with it, and therefore this relation is not a function. Now finally, we'll talk about the vertical line test and do a few examples. The vertical line test states that when you graph a relation, if any vertical line intersects the graph of a relation more than once, then the relation is not a function. And this is because every point on a vertical line has the same x-coordinate. If 2 points from a relation are on the same vertical line, then that means there are 2 points with the same x value that do not have the same y value. In other words, the same x value is paired with two different y values, so the relation is not a function. So example, is this relation a function? Short answer, yes. It's a function because it passes the vertical line test. Any vertical line drawn through a point on the relation only touches the relation one time. Next example, is this a function? Short answer, yes. This relation is a function because it passes the vertical line test. Any vertical line drawn through a point on the relation only touches the relation one time. Next question, is this relation a function? Short answer, no. It's not a function because it fails the vertical line test. It is possible to draw a vertical line that touches a relation more than once. And finally, is this relation a function? Short answer, yes. This is a function because it passes the vertical line test. Any vertical line drawn through a point on the relation only touches the relation one time.